Alright guys, so you watch 1 through 4, we got number 5 come up next, so let's see here. So a skater increases her speed uniformly from 2 meters per second to 7 meters per second over a distance of 12 meters. The magnitude of the acceleration as she travels this 12 meters is, so we're looking for acceleration. Right, but this is one of those constant acceleration questions, right? One of those 3 equations that we've used. So let's look at all of our variables and figure out what we have here. So I'm just going to list them all out. We have VI, VF, A, D, and T. Alright, so let's figure out which variables did they give us here. So skater increases her speed uniformly from 2 meters per second. So that's her initial, 2 meters per second. To 7 meters per second. That's her final, from 2 to 7. Right. Over a distance of 12 meters. That's a distance, 12 meters. And they want us to find A, find the magnitude of her acceleration. So the A is the unknown. So in this case, they didn't give us time, so we don't have to worry about it. So we look, 1, 2, 3, 4. Do we have an equation that deals with these 4? Yes, we do. VF squared equals VI squared plus 2AD. And we just plug in. So we have 7 squared equals 2 squared plus 2 times A times D, which was 12. 49 equals 4 plus 2 times 12 is 24 times A. Right, I need to get A by itself, so first I need to subtract 4 on each side. Right, 49 minus 4 is 45. And that's going to be equal to 24A. Now I need A by itself, so I'll divide each side by 24. Cancel on my right hand side. I'll be left with A equals 45 divided by 24, which is 1.875. So the answer here is going to be 1.9 meters per second squared. Right. So number 6. An airplane originally at rest on a runway accelerates uniformly at 6 meters per second for 12 seconds. During this 12-second interval, the airplane travels a distance of approximately... So let's look here. This is another constant acceleration question, so we have to look at all of our variables and then figure out which equation we've been given. So I'm just going to list them out. VI, VF, A, D, and T. Alright, so which ones are we given here? So let's look at an airplane originally at rest, so that's our initial. 0, starting at rest. Accelerates uniformly at 6 meters per second squared, so that's our A. Our A is 6 meters per second squared. For 12 seconds, so that's our T, 12. And travels a distance of approximately what? So they're asking us to find the distance. So in this case, there is no V final. So do we have an equation that deals with these 4? We certainly do. Its distance equals VIT plus 1/2 AT squared. Right, we just have to plug in. D is the unknown. VI was 0. T was 12. Plus 1/2. A was 6. T was 12, and that's 12 squared. 0 times 12 is 0. 1/2 times 6 is going to be 3. 12 squared is going to be 144. And that's D equals. In the end, we get D equals 3 times 144. So that's going to be 432. So in this question it says approximately, and the answer is going to be 430 meters. That's our final answer for number 6. Alright, number 7. A car starting from rest accelerates at 4 meters per second. What is the velocity at the end of 8 seconds? So again, this is a constant acceleration question. So let's list out our variables. VI, VF, A, D, t, and see which ones were given. So a car starting from rest. So anything that starts at rest has an initial velocity of 0. Accelerates at 4 meters per second squared. That's our A. 4 meters per second squared. What is the velocity at the end? So they want us to find the final velocity. The end of 8 seconds, so at the end of 8 seconds. They haven't given us a distance here, so let's look. Do we have an equation that deals with VI, VF, A, and T? It's going to be VF equals VI plus A times T. Let's plug it in. The VF is the unknown. VI is 0 plus A, which was 4, times T, which was 8. So this is just going to be equal to 4 times 8, which is equal to 32. And this is our final velocity, so that's meters per second. And that's number 7. So 8, we have a graph. An observer recorded the data above from the motion of a car undergoing constant acceleration. What was the magnitude of the acceleration? So remember, magnitude, they just want the size, we don't need direction. What was the magnitude of the acceleration of the car? So we have a little graph here. At 3 seconds, the speed was 4. At 5 seconds, the speed was 7. And at 6 seconds, the speed was 8.5. So we know that acceleration is delta V over T. So acceleration is equal to V final minus V initial over T. So let's look. Our final is going to be 8.5. Our initial is going to be 4. And then over T, how much time? How much time elapsed between when its speed was 4 to when its speed was 8.5? Well, it went from 3 seconds to 6 seconds. So the change in time was 3 seconds. Right? 6 minus 3. So we have acceleration equals 8.5 minus 4, which is going to be 4.5, divided by the 3 seconds, which is equal to 4.5 divided by 3, 1.5. So that's going to be meters per second squared. Alright, let's take a look at number 9 now. So in number 9, we have oil dripping at 0.4 second intervals from a car that has an oil leak. Which pattern best represents the spacing of the drops as the car accelerates uniformly from rest? So which one of these patterns is acceleration? Well, if something accelerates, the drops are going to be close together at the start. And as it speeds up, the drops are going to be further and further and further away. So the car is accelerated. So this is what constant acceleration would look like. It's the drip pattern like this. Now if the dots were all spaced out nice and even like this would be like a car in cruise control. This would be a car with constant velocity. If we saw dots like this, where the dots were far away, and then they started to get closer together, this means that its speed is decreasing. So this would be a car that's applying the brakes. And as it brakes, the dots are getting closer and closer and closer together. But in this question, you were looking for acceleration, so that's this one here where the dots begin to spread out.